So you want to make sure you got a good non-leaky capacitor before you do your real measurements.
Which one is
That's the CPD or the CSD, depending if you got a serial or a parallel model.
So you go CPD, you test that,
Yeah.
and then if it's low, you go back CPD.
You go back, yes, correct. Make sense?
Yeah.
So you can get all those, it's a separate test, but you can get a lot of information off of this AC bridge.
It's like a 4-step process.
It could be, yeah. If you're confident with your dissipation factor, then you don't have to do it, but I recommend you do it, just so you know you got good results.
Because we might have leaking
Yeah.
capacitor.
Because your error can go up real fast as dissipation factor goes up. Your error it'll still give you a measurement, but it's going to be off. It's going to be off due to the leak. There's a way you can calculate how much error based on dissipation factor as well, and it's in our manual. If you look in the manual, it kind of shows you that stuff. So, but you can get 50% error real quick with dissipation factors that are elevated. Okay, so
Sorry, what is the low number in this?
anything less than 1 is okay. You'd like to see 0.01 or even smaller.
Oh.
But if you start seeing numbers near 1, you got a problem, right? That's not good.
Near 1.
Yeah.
And you can see numbers above 1?
Oh yeah. Yeah.
So below 1 is okay.
Yeah. What magnitude of capacitance are you guys typically measuring?
Well, we make our own caps, so.
Oh, then this is good. Okay.
So
Actually, very
So it varies. It's all over the place.
yes, because we.
What's the smallest value you need to measure?
nanofarad or
Nanofarad.
maybe
So
Maybe
smaller.
picofarad.
Do you need to go smaller than that?
I don't think so.
we don't need to,
No?
but it might be there. So
Okay, because why I'm asking that is I know what that look is.
No, I'm listening.
It's not a time.
Oh.
We're not out of time.
No,
Okay.
we're good. Keep going.
Okay. There's a modification coming to the CV card that will allow us to measure smaller capacitances. We're changing the drive voltage. Right now it's plus minus 30 millivolts AC. We're increasing it to 1 volt. So we're going to have a 1 volt AC drive on a new modified CV card that will allow us to measure much smaller capacitances. So if you need that, let us know, and we can modify yours.
so what is the
It's a hardware
smallest this
modification.
system can measure?
I don't know offhand. This is still in the works. Maybe Shaw knows. Is he here?
Sorry, he's, yeah, take it all.
Oh, yeah, they can call. Maybe Shaw knows. It's some. I just found out about this 2 days ago, so I don't know the exact numbers yet. But
I think that should
some
be
customers are.
pico, right?
It'll
At
do
least
femto. It'll do
even femto,
femto.
That should be plenty.
Which
Yeah,
should be fun.
those ones.
Yeah. But some customers are asking for 2 volt AC drives. They want to measure really small currents. And another thing that we're looking into is the frequency. The frequency is we give you set frequencies. You can't measure at 1.5 megahertz, for instance. We're wondering if that's okay. We want to know. We want to hear from our customers. Is this something you'd like to see? Would you like to see more resolution on this, or is that okay? I mean, because we're trying to get some feedback to see if we need to modify any of this stuff.
I think it's okay.
Think
What's
it's
the
okay?
lowest frequencies?
1
Like
kilohertz.
Yeah.
And that's another question. Is that low enough for you?
1 kilohertz.
We have a I don't know if you're aware. There's a low frequency CV project on here
Okay.
where we can measure down to millihertz. We can go
Mhm.
millihertz. We go millihertz to 10 hertz. We can't do anything between 10 hertz and a kilohertz. That's a kind of a dead band for us. If that's something that's important to you, I'd like to know about that because we're in a place now where we're looking into making some changes. So if that's something you need, let us know. And the cool thing about the low frequency CV is you don't use the CV meter to make those measurements. It's such low frequency. We use the DCS and
Meant it's quasi-static?
yeah, it's similar to quasi-static. Yeah. We use the DC screws and we integrate current over time to calculate the capacitance.
And then it calculates the frequency for you, like it actually does it at a certain frequency.
Yeah.
Like,
We
okay.
turn it on and off.
Oh, that's cool.
Yeah, it's low enough frequency we can use the DC hardware to do it. We don't need the CV meter.
You know
But-
what it means? like basically normally you measure capacitance by applying AC signal, right?
With an AC bridge, yeah.
But what you can also do is just apply current and then integrate that current to see what charge you put on there
Right.
and measure the voltage
Over
or vice versa
Over time, right. And you can
and that's
calculate
the low
capacitance.
frequency then.
Yeah.
Yeah.
So the transient,
Sorry?
transient response of the DC.
Basically, yeah.
Yes.
Yeah.
Yes. The catch is, to use that, you need another preamp. You need to have a preamp on both sides. You only have one preamp, so you'd need another preamp to do that.
Basically, all this stuff we need more PM.
More money.
We will
Well, it's
need,
just money.
we need 3 more PM,
Um,
I guess.
We're looking at you.
We don't even have 3 bus
We have
through. We have 2.
Yeah, we just
2 bus
have
through.
one
We
preamp.
are planning for 1 more bus through maybe.
Yeah.
But again, since we had to instead of bus through, we can have the preamp 1 more.
Let me ask you this: Are you guys publishing any papers off the data you get off this machine?
We will.
Yes.
Yeah.
You will? You're not yet?
Well,
Because
we don't have
I
any
have-
data
This is
yet
the
from it.
results.
We need the data from it.
Yes.
No, but I have a concern. I notice your calibration's overdue. You don't
Yeah.
want to publish papers on a machine that's not calibrated. That's a credibility issue.
How far is it off? Like,
It's off from a time standpoint. It's supposed to be called once a year. It's all it's telling me that it's beyond its calibration date. I don't know if the calibration's off at all. It may not be, but it
Right.
needs to be checked.
but what
So
I'm
before you
asking
publish
is,
any papers, you should probably make sure that it's calibrated.
but what I'm asking is like if it's all over a year, you know, yeah, if you do the femtoamp or whatever measurement, then I can
You
see
might
that.
have a
But
problem.
what if you do like a nanoamp or something? Like how bad does it get? I mean,
I can't tell you that, but I can tell you that publishing a paper on an
Right.
uncalibrated system, somebody's going to question that, and then you're going to be like, oh, you know? So you don't want that. That's a bad thing. You don't want to
Yeah.
publish a paper.
Is there a way to know if it is not calibrated? I mean, in the
Send it
system?
Send it in. Calibration is not calibration like you're thinking. When I say
Yeah,
calibration, it's more validation than it is calibration.
Yeah.
So when you send an instrument in for calibration, that's what they do. They validate, is it within calibration? And if it is, they don't touch it. If it's within the tolerances, they just ship it back to you. If it's not, now it's calibration, right?
How
So-
long does that usually take?
How long does it take?
Process.
It takes them a day to do it. It's typically a week round trip because you have to send it to the U.S. It's got to go to it's got to go to Cleveland. We can send somebody here to do it, but you won't want to pay for that.
It's not easy work to pack
No.
everything same.
I understand that.
It's very hard.
But
I
is there any
understand.
way we can know if it's calibrated or you can validate it?
No, because
You can
there's
run
no
the
equipment
risk.
out there that's more sensitive than this.
Okay.
Do you have a meter that can measure femtoamps? I don't. It has to be done in a controlled environment, you know, humidity control, temperature control. It's got to be done with very, very accurate equipment. Nobody can do these except Keithley. Nobody
Maybe you
can.
can think to have some ECAL module so that
We can do it on site. We have a guy that can come here, bring equipment and do it. It's very expensive. If you've got multiple machines, maybe that makes sense. But, a lot of people they'll use like a local Cal lab, and they'll tell you that they can do it, but guess what they're going to do? They're going to send it to us. Because
maybe you can
because-
discuss
because
it, if
you
you
need
really
a-
want.
you need a very high-end metrology lab to
Okay.
calibrate this equipment
Even
because of
if
its
you-
sensitivity.
reading the femto.
Okay.
Yeah, but if you know.
So the reason I bring it up is because if we talk about upgrades, that's the time to upgrade.
Yeah.
Okay, if you're going to send it in for calibration, you want to add a preamp, that's the time to do it because there's a charge to upgrade,
Right.
and with every upgrade comes a full calibration. So you can send this in, add a preamp, you'll get a free calibration.
For Windows upgrade, we have to send it back or
No, you can do the Windows.
We
upgrade.
can do that.
Yeah, we will send you a thumb drive, and you can do it with the instructions on how to do the upgrade. You can do that. That's
Money.
not a problem. But anything hardware related, it's going to have to go to the factory.
Leave
I
me
mean,
more money.
because every SMU is in a slot, right?
yeah.
And the farther away the SMU is from the power supply, the more intense the calibration is, because there's capacitance of that backplane, right? So every instrument that's in this machine has to be calibrated in the slot that it's going to be in. You can't be calibrated outside the box. It's got to be calibrated in that slot. Because you move it over, now your calibration's off.
And what about the preamp? Yeah, we have one empty spot in the CVV module. If you want to order one preamp, that should be also be calibrated. calibrated for that?
It has to be calibrated with the SMU. The preamp and the SMU are paired.
Mhm.
They're tied together. You can't put a preamp 2 on SMU 1. It says on the preamp SMU 1. It has to go to SMU 1. It's that sensitive. It's a very tight calibration. Right? Now, here's another option for you. We now sell field installable SMUs and preamps for a premium price. You can get an instrument that's calibrated very tight so that it'll work in any slot. You can buy it, install it yourself, done. It costs a little more, but it still saves you money in the long run because you're not sending the system back. So that's an option as well, field installable.
But for the pass-through, I don't worry anything. I just connect myself.
Okay,
with
so the pass-throughs, the pass-through,
Yeah.
it's not a calibratable
Yeah.
device. So we can get you a pass-through if you want a pass-through, another pass-through, or we can get you another preamp, and then you don't need the pass-through because you already got 2 pass-throughs, right? So you probably don't, maybe you don't need the other preamp unless you want to do quasi-static CV, then you want the preamp. So that's up to you.
Maybe you can suggest if you want one more preamp, then and
Preamp's
otherwise-
about $3,000.
It's not too bad.
It's not too bad.
Rather
And there's a charge to install it.
I mean,
with
if you
calibration.
really need that, otherwise the pass-through is maybe $400.
Yeah.
Right.
You really don't need to pass through, to be honest with you. You just bypass the
Bypass
CGI.
it, yes, yeah,
you
understood.
don't
Just have a
really,
cable,
yeah.
right?
you just
Yeah.
ignore channel 4 on the
Yeah.
CGI. You leave it open all the time.
Mm.
You just don't use it. Where the pass-through would pay benefits for you is if you're doing any transistor characterization, capacitance, like you want to measure CISS, COSS, CRSS, those parasitics from pin to pin. The CVIV allows you to walk the CV meter around the device. So if you have a 4-terminal FET, including the bulk, there's capacitance between every pin to pin. Now that allows you to test all of those without having to repro, So you can do that in software. That's the benefit. If you're doing those kind of things, maybe it benefits you to have that capability. You can move the CV meter around with software.
We're not doing it yet, but if it's easy to do, then that might be.
Yeah, it makes it a lot easier because otherwise it's a cabling project, right? So that's what was the whole point of the CVIV.
Yeah.
Mm.
So we want to see the simulation actually with the transistor.
Simulate, yeah,
Yeah,
okay.
Yeah, the whole
That's what
process.
we started out doing.
Yeah, it was.
I had some ideas about your in situ
So-
project, so I'll come back later and we can talk a little bit.
No, thank you, sir.
Okay, so we got SMU tied to the source. So we're gonna take this guy, SMU1. So we're gonna find the cable
whole
for
process.
SMU1. This guy.
So
Yeah, okay.
do you think you will have time so that we can do some measurements on my device, if that's okay, for that voltage range?
Sure. I'm gonna connect. What I'm gonna do is I'm gonna follow the definition that's on here. So it says SMU1 is my source, which matches here. SMU1 is my source. SMU2 is my drain. So
He's moving too fast.
SMU2 cable. That's this guy.
He's moving too
You
fast.
should probably put some labels on these so you don't have to keep looking behind the machine. Put some labels. I think we give you labels, don't you? They might have this made in China label. You should mark them. Mark them so you know. And then SMU2 is my drain. So that'll go there. See, SMU2 drain. SMU3 is my gate. SMU3 is this guy. That's my gate. And I'm not going to, they're saying use the ground unit. I'm not going to use the bulk. We're going to ignore the bulk. Well, I'm doing the bulk because I'm going to say no. The ground unit is the connector that's up here on the back. Right? So if you want to use that, you have to tie another cable to it. I'm not going to use it. So I'm going to use 3 terminals. I got a drain, source, and gate.
Or you can also put the working center there.
I could.
Yeah.
I could. But there's the bulk. The only thing you're going to measure in the bulk is capacitance, right? So you typically you'll measure from gate to bulk to get capacitance. But right now we're doing a family of curves. We don't need it. So there's our connections to our device. This is my SMU4 here. I'm going to use that. So this is showing you. I'm going to do a step, and I'm going to do a voltage step, as you can see. for the SMU. I've got a whole
It's
bunch of
supposed to
different
be
options.
nice.
You all understand these options. You know what a list sweep is. List sweep is just a list of values. You can literally import a spreadsheet into it. So you can do arbitrary waveform generation. It's for the list sweep, voltage list sweep.
Oh, okay.
You could put any voltage you want, one after another. So you can go positive, negative. It's bipolar.
So it gives me the option to choose a spreadsheet, for
Yeah.
example.
So
Yeah.
here I could go voltage list sweep, enter values, and I can just go right down this list. It'll go one after another, and that's what it'll source. Right? And there's a way you can import spreadsheets into it if you want.
And does it go from minus, for example, -10 to +10 without sweeping?
Minus 200 to plus 200.
Without sweeping, like,
What do you mean without sweeping?
like value.
While sweeping, it'll do it.
Point
So
measurements,
it'll
you mean?
sweep from -100 to +100.
Any discrete value.
In discrete values.
That's the point.
Yes.
You can
It's digital.
Continuous wave with
Right?
discrete
It is
value.
digital. Okay.
Yes, it's digital.
That's what I'm asking.
It kind of shows you that. Here, let me go back to it. Oh, get out of here. It kind of shows you that it's digital when you look at the voltage step. You know, so it's-
Yeah, we'll
and even this, it looks analog, but it's really not. It's a step, right? But if you use enough points, it looks analog, right? So you can decide that. How many points do you want in your sweep?
Yeah.
If you need, typically, so for the gate, we're typically gonna go 0 to 4 volts. Let's go 0 to 4 volts on the gate, and let's do a 1 volt step. So what that's gonna do is that's gonna
Isn't high 1 voltage per step?
no. Actually, better yet, nothing happens at 0 volts. So let's start at 2. Let's go 2 to 4, and let's use a 0.5. Yeah, let's do that. 0.5 volt step. So that's going to give us 4.
4 1.
That's going to give us right. It's going to give us 4 curves, right? So one at 2 volts on the gate, one at 2.5 volts on the gate, one at 3 on the gate, one at 4 on the gate. So you determine what you want here. And then, so we have to set a compliance. Do we all know what compliance is? Yes? No? Okay. If you're sourcing a voltage, you need to set a current compliance. If you're sourcing a current, you need to set a voltage compliance. What it is it's a way to protect your device.
Yes.
What that says is that's the highest current that source meter is going to source. So if it hits 0.1, if it hits 100 milliamps, it will shut off if you want it to. You can tell it to shut off on compliance or just give you a warning on compliance. You can set up either way. So that's a way to limit the energy you're putting into your device. Say you've got a short or a bad device, you can protect things that way. Okay. So it's yeah. And another important thing here is that every SMU has 2 A to D converters. They can measure voltage and current, time correlated at the same time. So some of the SMUs you may have, the Keithley boxes, they only have 1. This has 2. So that's important if you're trying to measure power, for instance. You want your current and your voltage measurement done at the same time. And some of the other instruments, it has to do 2 sweeps, one for voltage, one for current. Now you don't have any time correlation. This has time correlation. So it can measure them both at the same time. I'm not going to measure current on the gate because gate current, as we know, is very, very small, right? Very, very small currents take a very, very long time to settle. This test will take a long time to run, so I'm going to ignore that for this test. Then I'm going to do a linear sweep, just kind of showing you that here on the drain. And now this is typically where you're going to want more resolution, you know, but we'll leave it at 0.1 for now.
It's okay. It's okay, we're just testing.
Yeah, yeah. And here I'm using an SMU to give me a ground in my source. So I'm saying source 0 volts. Okay. If I use the ground unit, for instance, I'll show you the difference. If I use the ground unit, it doesn't let you measure. There's no options for measuring. Okay. It knows that I'm just sourcing the ground. That's all I'm doing. It doesn't give you any other options. So by using the SMU, I can source a better ground, and I can measure current if I want to. I can measure current, and I am. And I can measure current on that lead. Okay.
So actually, I have this question. So we are sourcing voltage, right?
On here, yeah, 0
And
volts.
then it says measure current, report voltage. What does that mean? So
Don't really need it. I'll show you. But we don't really need it for the ground. I mean, do you want to know what your ground current is? Probably.
So each SMU,
Each SMU
sources and measures at the
Yes.
same time.
Yes.
Cool.
That's
source measure unit. That's what SMU stands for. It sources and it measures.
Same
Okay,
time.
so when we
At the
want
same
it to
time.
source and we want one other SMU to measure,
That's a different thing.
This is just sourcing because I'm not measuring anything.
okay,
I turned off the measure, so this is just a source.
okay.
Okay, this is a source measure because I'm sourcing and I'm measuring voltage. You see?
Yeah, port voltage, okay.
Okay. So an SMU is very versatile. It can do just about anything you want it to. By the way, it can be an electronic load. It can sync power. Okay, which is very cool. So if you want to test a battery, a solar cell, it will sync energy. It's a 4-quadrant instrument. It'll work in all 4 quadrants. It will switch on the fly between sourcing and syncing as well, which is very cool. It's a great instrument that a lot of people don't even know about. Yeah, it's very cool. And the way you'll know if it's syncing is you'll have a sign change between voltage and current. If your voltage and your current are both positive, you're in quadrant 1, right? If your voltage and current are both negative, you're in quadrant 3. Quadrants 1 and 3 are sourcing quadrants, like a power supply. Quadrants 2 and 4 are syncing. So if you have a positive voltage, negative current, that means the machine is measuring energy being sourced into it, right? And the same if you're in quadrant 4. Okay, so that's important to understand. You might see in some situations where it might briefly go into one of those syncing quadrants and then come out. And that's because of charge on your cables or on your device. And you might be changing from an elevated state to a lower state. That charge has to go somewhere. It's going to go into the SMU. Not only can it handle that, it'll tell you that. It'll let you know that it did that, and it'll measure it for you. You do that with a power supply, you're going to let the smoke out of the power supply. And when you let the smoke out, they don't work anymore. So a power supply doesn't like to have energy sunk into it. This can handle it, and it loves it. You can do it all day. So you can tie SMU1 directly to SMU2. You can drive SMU1 to 200 volts, and the SMU2 will measure that 200 volts and that current for you. It can handle it. Whatever it can source, it can sync. So from that respect, you can't damage it, right? So whatever you can source out of one SMU, you can measure out of the other. The only way you can do damage is if you gang up 2 SMUs on one. You put 2 in parallel, which you can do. If you need to double the current, you can put 2 SMUs in parallel and you'll get double the current. But now you have to be careful, because now if those 2 gang up on one, you could do some damage. Okay? Otherwise, if you don't do that, you'll never hurt anything. You can't do it. It can take it. It'll do it all day. Okay, so that's basically our whole setup. Now, our test settings, we have a speed issue here, and we have timestamps. We usually want to turn on timestamps, so it'll put a timestamp on every measurement. Yeah, it's nice to have. There's sweep delay and hold time. But this is the, we talk about the SDM cycle. This is the D, right? So this is where you can add additional delays. The sweep delay, you can add additional delay after every source change. So every time you make a source change, it will wait a little longer than the predefined delays, right?
Basically to get to steady state.
To get a more stable measure, yes, to get to steady state. The whole time is delayed before the sweep starts. So like to charge up cables or things like that, you can do that. Because sometimes you might have a test that doesn't start in the off state, it might start in the on state. Because you could leave an output on after a test is done if you want, so that it's on for the next test. Okay, there's a way to do that as well. And I think that's done here. Is it? No, it's not done there. Yeah, right here. Disable outputs at completion. So with this on, it will always turn off when the test is done. But if you click that, it'll leave it on. Okay. Okay, so then we go to the analyze, and this is what we should get if everything works right. If everything works right, we should get that. Let's see. There it is. Okay. And I can show just the graph if I want. Oh, we got 5. Okay, I did the wrong voltage. Or I can look at just the data. Here's my timestamp. So what are we at? About 200 milliseconds per step. We can go faster than that if we want. That's what we're seeing. So you see the indexes 1, 2, 3. That's the different curves, right? The first curve, second curve, third curve. So you got all your data. You can export this if you'd like. You can go to save data.
Yeah.
And we can write this out in the graph we can write out in 4 different formats: bitmap, JPEG, PNG, or GIF. And then we can also do the same with the sheet we do it. I think it's an SLSX or CSV.
XLSX.
Yeah. So you can output that
CSV is
data.
also possible.
Thumb drive, you put thumb drive right in the front, output right to the thumb drive. Or you can connect this to your network, and you can save right to a network drive as well. Okay. None of your data ever gets thrown away in this machine. Any test you run gets added here to the side. So you can go back later on if you want and compare runs. What you can do is you can make a reference run. You got a known golden device. You can test that device and give it a name. This is my golden device, and then you can do a run and you can compare. You can compare results. Like I can go here and I can add run 4 to run 3. See, so I can overlay them. If I want to see the difference, I can zoom in on a section like that, and I can put cursors in here to actually measure the differences, things like that. Okay. A lot of settings here. A lot of settings. Let's turn this guy off. There's a lot of settings here for line fits and zooming and just typical graphing stuff, just like you'd have in Excel. You can do all that here. I want to show you the formulator. The formulator is important. The formulator. So here's a test where I need to find the slope, right? I need to find the threshold and the slope. I can write formulas to do that. Once I do my sweep, I can write formulas. There's what we call a formulator. Find it.
There's the option if define graph, so you can.
So right here, there's a formulator. So I go to the formulator, and there's already a formula in here. There's a bunch of formulas, so I can write formulas in here to post-process. And here's the data that the machine collected that I can use in my formulas, and here's all the functions I have. It has built-in constants, or you can add your own. You can add your own constants, and they stay in there forever, right? So that's kind of cool. So you don't have to keep entering all these long constants, So that's all there for you. Got some typical math functions, that you can use. You can apply new formulas just to certain runs if you want, so you don't have to apply them to all your runs, or you can apply them to all your runs, so you can see the data later on after the run's been there for a while. Now you can add formulas and go look, apply them to data that's already been taken, right? Instead of having to rerun the test. So that's very powerful. It's a very powerful feature. So for instance, like this V threshold is finding where the device breaks, and you'd have to go through the manual to understand all the commands and stuff. But it's pretty.
There's a formula.
Yeah, there's a in the manual it has all this stuff defined, pretty easy. And then this is a line fit. You see, it kind of makes sense. At a certain drain current, you want to put a cursor in another drain current, another cursor. You want to find the slope between them, things like that. Okay, so that's pretty cool. The sub VT is similar. Sub VT is similar to this. Should run too, by the way. This device. So that's right. And you'll see it puts all the data down here from your formulas. It puts it all down in here. And then after it's done, I can even go in here.
The slope,
Yeah. And I can drag these around, and they see the data changes. Pretty cool. So that's what I said. You might not even need Excel. You can do a lot of stuff right in here.
You can export this graph and just put it.
And you can export the graph. Yeah. You can add labels and all kinds of stuff, legends, and you can do a lot of really cool stuff. I don't want to go into that. Not real important. But all these tests kind of show some different features. This one should run too. See, now the other cool thing here is, like I said, you could run these tests sequentially, right? So, what's that? That looks like a bug.
You can select everything and just run everything and come back
Yeah.
later and find everything.
Yeah, I'll show you that. Oh, that's kind of weird. I don't know what's going on here. But for instance, let's say I want to run these tests all together. So if I want to run these 3 tests, what I do is I go up to this level and I hit run.
But if you want to run every
Yeah, and now it's gonna go down, see, it's telling you which one it's running,